This tutorial is a relatively simple exercise designed to reinforce your skills and understanding of some of the most basic features in Solidworks. As you can see, we have a little toy train, and it is constructed using 6 different types of features that include extrusions, cuts, revolves, fillets, patterns, and finally mirrors. This exercise was also designed to introduce you to some options available in these different basic features that you may not yet be familiar with. For example, we're going to take advantage of the fact that the train is symmetrical and build one half of it so it sits in front of the front plane and the other half so it sits behind it. This will conveniently allow us to use the front plane as a mirror plane when it's time to make a mirror image of the wheels. To be able to do this, we will have to be using some extrude options that up to this point we have not yet used in order to allow us to extrude automatically in 2 different directions. The entire exercise comprises 14 different features, which we could probably do in fewer features, but this exercise was designed to break it up into this many features in order to introduce some key concepts. Using the rollback bar, I will quickly introduce each step and then go back again and show them in detail. The first feature is what I'm calling the top deck, and this is a simple extrude with the sketch being made on the front plane. We'll be using a feature called midplane extrusion that gives us an extrusion going in both directions. The next feature is also an extrude for the cab. This will also go in 2 directions, but we're going to use an option called up to surface to guarantee that this face of the cab lines up with this face of the deck and this face of the cab lines up with this face of the deck. The next feature is this top curve, which is made with a cut. It has a unique feature built into it. And then the overhang of the cab has a simple fillet. The boiler is nothing more than a simple extrusion starting on this face. And then we add another midplane style extrusion to represent the undercarriage. Extruded from the undercarriage will be a drive wheel and a front wheel, and then we'll pattern this front wheel to get a second wheel. All 3 wheels will be mirrored to the other side of the train using the front plane as a mirror plane. The smokestack will be added as a revolve, and what's unique here is we'll use the thin wall option for the revolve in order to create a hollow smokestack. A cow catcher, a wedge shape, will be added to the front using again the up to surface option. And then from the top we're going to do a cut in order to add this wedge from this viewpoint, and then we're going to finish it all off with a simple extrusion off the front of the boiler to create a headlight. Now let's go back to the beginning and see how each of these were done. The top deck is a sketch drawn on the front plane. This lower corner is aligned with a coincident relation to the origin. You can see in the highlight here that this extrusion is going to be going in both directions. Let me show you how that's done. Normally we're used to using a blind extrusion that goes just in one direction. What we're going to do instead is use the midplane option, 3 inches wide, and what that does is extrudes one half of the extrusion in one direction, one half in the other. So the total will still be 3 inches, but one half will go in this direction and one half will go in this direction. The cab is also drawn on the front plane. We want to make sure that this lower corner has a coincident relation to the upper corner of the deck to make sure that these are always in contact here and here. One thing you want to be careful of is not to accidentally introduce a midpoint relation right here with respect to the deck, or it will make your dimensions create an error. Now instead of using the midplane option here, first show you what the blind option looks like. What we want to do is extrude this up to this surface here and extrude in a second direction going to this surface here. That guarantees that no matter how wide the deck is, the upper cab here will always be the same width. So once again, we'll take it out of the blind option. In this case, we'll go up to surface. We're going to select this surface of the deck. We see that now the cab is going right up to this surface regardless of what this dimension happens to be. Here we see only 1/2 of the deck has been created. The normal default is to keep direction 2 turned off. We're going to check direction 2 to activate it. It defaults to blind also. We're going to change this to up to surface. And we're going to click on this surface of the upper deck in order to make sure that this side of the cab is also in alignment with this side of the deck. The next feature is cutting away this top curve. This is pretty straightforward with one exception. I'm going to draw a sketch on this face. And what's different about this from what you're accustomed to is we're going to just draw a single open arc, and we're not going to make an enclosed two-dimensional profile like we normally do. We can do cuts this way, but when we do a cut that is not an enclosed profile, Solidworks automatically defaults to doing a through all option going in both directions. And we also have to tell Solidworks whether we want to remove the material to this side of the cut or to this side of the cut. So I'll show you how that's done. I will just redo this cut here. I'll roll back, click on this surface, select sketch, and I will use the 3-point arc here. And the easiest thing to do in this case is just click 3 different places. Don't worry about it being aligned with any of the features yet. Now what we're going to do is add a coincident relation between this edge and this point, and a coincident relation between this edge and this point. You see it's up high in the air here, so I'm going to drag this down. And be very careful to stay away from the middle of this segment, or you might accidentally add a midpoint relation, which you don't want to do. If you accidentally do that, just delete the relation and make sure you only have a coincident relation. The last relation we want to add is a tangent relation between this arc and this edge here. That will mean that this arc just barely touches this edge. I want to remind everyone that the easiest way to add a relation is to hold your control key down and then select the 2 items that you want to make a relation between. This automatically opens up the Properties Manager for relations, and here we see the only feasible one is tangent. I'm going to add a 4-inch radius to this arc. And we see that this is still blue, meaning that something isn't quite fully defined. Whenever you have a question as to what's causing something to not be fully defined, what you should try to do is just grab a point and see how you can drag it around. And that sometimes gives you a hint as to where the problem is. So we can see that we can make this arc seesaw up and down. That tells us that somehow these endpoints have to be constrained in a vertical direction. Not only that, we want to make sure that this, see I accidentally added a midpoint. We want to make sure that this point is at the same height as this point. To make sure these 2 points are at the same height, I'm going to add a horizontal relation with them, which is the same as putting them on a common imaginary horizontal line. So once again, I'm going to pre-select the points holding down Control, choose horizontal, That's brought the points across, directly across from each other, and it's turned the line black. Now I'm going to use this line to make a cut. Go to my Features tab, Extruded Cut. And here we see that the blind option isn't even available. In fact, the only option available now is Through All, and it's automatically activated Direction 2, which also is in the Through All state. Here we have an arrow telling us which side this material is going to be cut away. If I toggle this with the Flip Side to Cut option, I see that the arrow flips up and down. We want the arrow pointing upward to get rid of this material. If we make the wrong choice, we can always go back and re-edit the feature and change it. So here we see we have a nice curved cut, and this is a smooth curve with no flats or extra material left over because of the tangent relation that we used here. The next feature is just a simple fillet put into this inside corner. No mysteries there. I'm going to revolve this around so we can view the train from this direction, and we're going to add the circular boiler as an extrusion starting on this face and extruding in this direction. So just roll this forward, edit the sketch. We see that it's nothing more than a round circle. In order to keep it on the center of the train, we have a coincident relation between the center of the circle and our front plane. The circle is 2.5 inches in diameter, and it's 1.5 inches above the origin, which is the same as 1.2 inches above the top of the deck. You'll notice that I purposely have a little bit of an intersection between the circle and the top edge of the deck. This will guarantee that this boiler is not just barely touching the deck. If it does, we'll have a little bit of a problem. Avoid using the tangent command in this case. So this is one case where we actually are going to use a blind extrusion. It's just 4.3 inches away from the front face of the cab. The next is the undercarriage. This is what the wheels will be attached to. And this is a simple rectangle. The key thing is to also make a coincident relation of this upper right corner to the origin and another coincident relation of this upper left corner to this lower corner of the deck. This will guarantee that the ends of the undercarriage line up with the deck at both ends, and that this top edge of the undercarriage is always in alignment with the bottom edge of the deck. Once again, we're going to use the midplane option when extruding, only this time we're just extruding 2 inches wide. I'll show you what that looks like. So here's our property manager for the extrusion, 2 inches wide, midplane option. So we intentionally do not want the undercarriage to be the same width as the cab and the deck because we need to fit some wheels under here. The drive wheel is nothing more than a circle that is drawn on this face of the undercarriage. And this is a blind extrusion of 1/2 inch going this direction. It's dimensioned with respect to the end of the undercarriage and the bottom of the undercarriage, and has a 2.5 inch diameter. The front wheel is almost as simple. It's also drawn as a sketch on this face of the undercarriage. One thing we have to make sure of is that the bottom of the front wheel is in alignment with the bottom of the rear wheel. To do that, in the sketch, what we want to do is add a construction line that is tangent both to the bottom of this new front wheel we're adding and the bottom of the rear wheel that was already created. And then this line has to have a horizontal relation on it. And then the front of the wheel is dimensioned with respect to the front of the undercarriage and has a diameter of 1.5 inches. This is also just a simple blind extrusion. Could have just as easily drawn a second wheel, but for fun we're going to pattern this. So what we want to do is give a direction we are going to pattern in and the distance between the center lines of the wheels that we're going to pattern. So go ahead and pattern this. If I highlight it, we see that we want a total of 2 wheels, dimension of 2 inches apart. I'll open up the Properties Manager on that. You can see the edge that was chosen for the direction was this bottom edge of the carriage. This determines that the pattern will go this way and not, for example, this way. Here we selected 2 inches, which is the distance between the wheels, and here we selected a total of 2 instances. Remember that the first instance is always the original one. In this case, the second one is the patterned one. And in this box here, we've actually selected the item that we are patterning, which is step number 8, the front wheel. So now we have 3 wheels. We don't want to go through all the work of making them again on this side of the train. We're going to take advantage of our mirror command to do a lot of work for us. Mirror command can be found up here, or it can be found under the linear pattern grouping. Linear patterns at the top, and when we open this up, mirror is also found here. To do the mirror, we have to tell SolidWorks what we are going to mirror about. So imagine that this is our mirror and that these 3 wheels are going to be reflected in it. The distance between the wheels and the mirror will be the same distance that the mirror image will be copied from the mirror plane. So if these are 1.5 inches away on this side, the mirror image will be 1.5 inches away on this side. So in the mirror face or plane, we will select the front plane. Now it's highlighting the features to mirror. We're going to choose this wheel, and this wheel. You see it's highlighting to the other side, and we just complete the command. The smokestack is revolve. The sketch for it is also drawn on the front plane. The sketch for this has 2 primary elements. One is the central axis that the revolve is going to be spun around, and the other is the actual outer profile that's going to give us the shape of the revolve. In this case, we want a smokestack which is hollow, so it's open on the top. This can be open on the bottom. We only have to draw 1, 2, 3 line segments to achieve that. We do not need a horizontal line segment to cap it off because we want it open on the top. We do not need a horizontal line segment on the bottom, nor do we need a solid line segment on the center. It's important that this line be a center line. I'm going to delete a few of these dimensions and demonstrate how we can take advantage of dimensioning something which we know is going to become circular after the revolve. So here is the outer perimeter of my smokestack, and I want to dimension what the diameter is going to be of the bottom portion of the smokestack. If I dimension from the center axis out to the edge of the smokestack and drag in this direction, it tells me 1/2 inch. If I drag in the opposite direction, it tells me 1 inch. It automatically doubles the dimension for me to tell me what the final result would be if this was revolved. That way I don't have to do any math in my head. I can add another dimension here, from here to here, and then drag to this side, and we get 2.5 inches. And then finally, from here to the center line, again you see 1 1/8 inches, and if we drag to this side, it's 2 1/4. I'm purposely bringing the bottom of the smokestack a little bit below the top of the boiler because of the fact that the boiler has a curve to it. I want to make sure that the smokestack is completely buried into the boiler without any edges hanging out. Now let me show you the options we will use for the revolve command. Go to Features, Revolve. It will tell us that the sketch is currently open. This is because we did not create an enclosed two-dimensional profile. This is intentional. It says, would we like the sketch to be automatically closed? In this case, we are going to say no. Under these conditions, SolidWorks assumes that you're going to have to make what's called a thin feature. So it's okay to make a non-two-dimensional enclosed profile, but you have to add thickness to it in order to get the same effect as an enclosed profile. SolidWorks lets you then choose what the thickness of this profile should be. In the highlight here we can see my profile. We can see that SolidWorks has automatically added thickness to it at the same time that it is revolving the profile. It's also assuming, because there's a center line in my sketch, that the profile is going to be revolved around that center line. You can see if I increase this number, the thickness of the revolve increases. We also see that we have a one direction option activated, and if I toggle this, the thickness goes inward instead of outward. I have other options such as midplane, where half the material goes inward, half outward, and the other is two direction, which lets me have a different amount going outward than going inward. We are going to use one direction, going to make sure it goes inward, and we're going to make it 0.1 thick. We even have an option as to how many degrees we want this revolve to go around. The default, of course, is 360 degrees for a full circle. If I wanted to, I could always make that something else like 180 degrees or 90 degrees or anything I desire. We're going to make that 360 to make our complete smokestack. Finally getting close to the end. Next step is to add our cow catcher. This is nothing more than an extrusion, a trapezoidal shape. It's got a coincident relation to this upper corner of the deck and the lower corner of the undercarriage. It's often easy to draw a trapezoid like this by first drawing a rectangle and then take this vertical line and delete the vertical relation on it, and that'll allow you to make this line go at an angle. The options on this are up to this surface and up to this surface to guarantee that the width of the cow catcher is the same width as the deck and the cab. To finish the cow catcher, we want it to also have a wedge shape when viewed from above. On the top plane, we will draw a simple sketch. It's just simply two lines going from this corner to the midpoint of the front edge of the cow catcher into this corner here. We'll use the cut command once again, and because this is an open profile, it's not an enclosed two-dimensional profile, it will automatically default to through all this direction and through all in this direction, and we want to make sure that the cut goes to this side, not to this side, in order to remove these two triangular areas. I'll show you what the Properties Manager looks like on that. So here we see it's automatically defaulted to two directions, through all in both cases, and we see the arrow is flipped to this side to cut to the proper side. Finally, we're down to the last step, and this is probably the easiest. Just the headlight on the front of the boiler, just a circle which can be made concentric to this edge of the front of the boiler and extruded outward. And that's all of it. A couple things to notice. Once again, I want to remind you that the boiler, the bottom should come a little bit below the top surface of the deck. So you see we have this little flat area as a result. And also because we purposely made the smokestack come down below the top of the boiler a little bit, that guaranteed that the smokestack is completely intersecting with the boiler, and you can see how it's sort of wrapping over the top of the boiler. Finally, I'm just going to demonstrate here. If I take the top deck, which has a 3-inch width, I go ahead and modify this width, say make it 4 inches instead of 3, you hit the rebuild button, we see that not only did the deck get wider, but because of the up-to-surface feature we used both for the cab and for the cow catcher, we see that those features get wider at the same time in order to keep them flush all along the side. We see that the undercarriage, though, remained at its original 2-inch dimension, which makes the wheels look more tucked under than before.